This video is to help you with section 8.1.2, comparing distributions. Again, you do not need to copy down the classwork, but we will go through it, and I will attempt to do it for you to help make sense of the concepts. So the idea is that we're comparing distributions today. And so for 819, it says Josh is just starting a round of golf. The first hole is 130 yards long. He needs to decide which club to use for his first shot. He has kept careful records about how close his first shots came to the hole, all from the same distance. His records include data from his use of two different types of golf clubs, a wedge and an 8-iron, over the past year. So for the wedge, when he used the wedge, when he made the golf shot, he was 0 yards away from the hole, then 3 yards, 1 yard, 2 yards, and so forth. When he used the 8-iron and made the shot, he was 19 yards away from the hole, 12 yards, and so on. They want a histogram and box plot for each of the clubs, and this is something we haven't done before. They want the box plot above the histogram. So again, we're going to go ahead and do that together to help you understand that idea. So for the wedge, we would take the set of data, and we would start, of course, by looking at the data and putting it into the histogram. And for the histogram, remember, they tell us that they want the bin width to be 5 yards. So that's why we know that we are set up with 0 to 5 to 10 to 15. We're going by 5s along the bottom. And then the frequency, of course, is how often that occurs. So 0 to 5, we have 1, 2, 3, 4, 5 shots that were between 0 and 5. Remember, the 5 itself goes into the 5 to 10 bin. So we would go ahead and make our height of our histogram to be 5 here for the 0 to 5. Okay, so I'm going to go ahead and do that. And then from 5 to 10, we have, looks like 1, 2. So 2 of those shots were between 5 and 10 yards. So we'll make the height of the histogram to be 2 there. And then from 10 to 15, we actually don't have any, because remember, 15 would be in the 15 to 20 block, or 15 to 20 bin, I should say. So we'll have nothing in this 10 to 15 space. For the 15 to 20, we're going to have just the 1, the 15. So the height of the bar there will be just 1. For the, oops, I'm sorry, I've got that in the wrong space. After I just said differently, I put it in the wrong space. So let me fix that. This is in the 15 to 20 bin. For the 20 to 25, we're going to have also just a height of 1, because that's going to be the 22 here. So the height of the histogram here will be just 1. And then the 25 to 30 will also be a height of 1 because of, and I'm trying to do different colors here to separate them, make it easier to see, because of the 25. So we've got a histogram that basically looks like this. Now remember, one of the things we've been doing recently is talking about, what do the histograms look like and so forth. One thing you could talk about with this is it's very skewed. Most of the data is over here. You could also talk about that it's not very symmetrical. You don't see symmetry on both sides of the median space. So it's not symmetrical. You could say single peaked. So single peaked and skewed, probably the way that you describe that histogram. Now, how do we then do the box plot above that? Well, the nice thing about doing a box plot above it is you already have the scale on the bottom here, so you don't have to redo that. But what you are going to do is take that set of data and put it in order from least to greatest. So in order to do a box plot, we have to put the numbers in order, find the median, find the quartile 1, quartile 3, and so forth. So I'm going to go ahead and just put down the numbers in order. So I've got 0, I've got 1, 2 2s, 3, 5, 7, See, it looks like then we jump to a 15, 22, and 25. So I'm just going to double check, make sure I'm not missing any. So that's important before we go through all the efforts of finding the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like we have all the values. All right, so then what we want to do, remember, when we make a box plot, is find the median. We want to find the middle value. So we are going to find the middle of the set of 10, realizing that when you have an even set of numbers, your median will be halfway between two values. In this case, halfway between the 3 and the 5. So of course, what's halfway between 3 and 5 is 4. So the median of this set of numbers would be 4. Now, how do we draw that on terms of including it with our histogram? Well, we go ahead and find where 4 would be located along the bottom here. And we'll put a vertical line, try to pick a color that'll show up here nicely, a vertical line at the 4. Just remember, when we make a box plot, we always go ahead and put a vertical line at the median. So I'm just going to go ahead and put a 4 above that because it's hard to tell if that's meant to be a 4 or 5, 4.5, whatever, unless we label it. And maybe I could make that number a little smaller, but for now I'll stick with the 4. Then we're going to go ahead and find the first quartile. So remember, the first quartile is the value that is halfway between the first set of numbers, halfway between the lower set of numbers. So we've got these 5 numbers. We're going to find the median of the first half. So we're going to cross out here, here, till we find the median of the first half, which is 2. So our Q1 value is 2. We're going to go ahead and make a vertical line then at where 2 would be located, which is about here. Again, we'll put our number above it. I maybe need to make these smaller. We'll just see. Looks like I probably will, but for now, we'll make them nice and large so you can see them. Remember, that's not a 24, that's a 2 and a 4. All right, then we're going to find the median of our second half of our numbers, or our upper set of numbers, so our Q3, and that is going to be 15. So Q3, quartile 3, would be at 15. So we're going to go ahead and make a vertical line then at 15. So that'd be located here. And again, we'll put our 15 above it. Then remember, to make a box plot, what we're going to do is connect our parts of the box. Okay, so I'll move that so it looks a little better. But we have the 15 for the quartile 1, we have the 4 for the median, we have the 2 for the quartile. I'm sorry if I said 15 for quartile 1, I meant quartile 3. I don't know if I said that correctly or not. 15 is quartile 3, 4 is the median, 2 is quartile 1. Okay, so that creates or completes our box. And again, we just didn't have to make the bottom set of numbers because we already had them, and we don't worry about the frequency because that's only part of our histogram. This is a separate item with our box plot. Then remember, when you make a box plot, you take the whiskers out to the lowest and highest value. Our lowest value is 0, and our highest value is 25. So I'm going to go ahead and have the whiskers, as we call them, go to the lowest value of 0 and the highest value of 25, which I can write those in. The 0 is going to be hard to have it show separately, but I'll do my best to show that as well. All right. So that is how we do a combination box plot and histogram. Now we could do the same thing with the 8-iron data. Again, we would do it over here. I don't think you need that additional example, but this is something that hopefully is a good review of the histogram and a good review of box plot. And now we're putting the ideas together. All right, and then when we want to talk about typical values, you have to think about whether you would use median or mean. So again, as you look at this information, we know that the median is 4. We could find the mean by adding up and dividing by how many there are. and you'd want to think about what seems like a more typical value. Remember, when there's outliers, values are a lot bigger or smaller than the others, then you probably would prefer to use the median. And it looks like there's these outliers. Especially these last two numbers, are a lot larger than most of the numbers in your list. So median is probably the way to go. Then for 820, it says it's important to consider the spread of the data as it is to consider the center. Again, center would be your typical value. So they wanted you to find the interquartile range for the golf clubs to see where he was more consistent as a player. So again, remember to find the interquartile range. That is the difference between your quartile 3 and your quartile 1. So your IQR, or interquartile range, would be 15 minus 2, or 13 for this club. So for the wedge, we would take the 15, which was the Q3, minus the 2, which is the Q1, to get 13. That's our IQR. Okay. So again, we could do the same thing with the other club, but that is how you would calculate that. All right. And then they had you doing some additional information on 821. Remember, the idea of a parallel box plot is that you have one box plot above the other. All right. So if you were looking for this set of data, you would take, and let's just go ahead and do it so you have the example. It says Mr. Webb has only one more starting position available on his basketball team, but 2 students have tried out for it. He wants to choose the students that's more likely to score the most points. These are the 2 students he's looking at. Here's Jana's points in her games, or in her recent games. Here's Alejandra's points in her games. And we're using the idea of parallel box plots, which are 2 box plots on the same number line, to justify which player he should pick. So you would start by putting again your data in order, which I did for you. Okay, so you would take Jana's numbers and Alejandra's numbers, and you would start by creating your box plot. Now remember, there's different number of games here, but that's okay. All right, that doesn't make any difference. You start by finding your median. All right, you'd work your way to your middle and so forth. And I think I found the median for you. Yep, the median for Jana was 9. Okay. And I can show you that here as well. Again, it's good for us to see that, even if you don't have to copy it. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers. So it makes sense the median was between these 2 in the middle. That's how we got the median of 9. Remember, when you have a median between 2 values, you look for your quartile 1 to be in this lower set of numbers, and your quartile 3 to be in this upper set of numbers. And what you find is your quartile 1 should be 7, your quartile 3 should be 11. Now, I'm not taking the time to go through that with you. Hopefully you've done enough box plots to know how to do that. But just as a quick example here, you would then, mark your median, which is 9. So you can put Jana on the top or on the bottom. It doesn't really matter. Let's just go ahead and put her on top since she's the top set of numbers here. Mark your 9 for your median. Okay. Then you're going to mark your first quartile at 7. Just very close to, of course, the 9. So again, maybe smaller print would work better in terms of the typing here. And then you're going to mark your third quartile, which is the 11. So also very close. Means her IQR is very small. She's a pretty consistent player. Okay, you would complete your box. And then you would do your whiskers. The lowest value and highest value. Her lowest was 6. And her highest was 55. Okay, so we'd put the 6 and the 55 then for the ends of our whiskers. All right, so that's how we would do the one box plot, and we would put, color you can see the whiskers for ends for. we put, next to that or above that or something that's Jana's data. Okay, and then if we want to do a parallel, it means the other one's going to be below it. So for Alejandra, again, we put the numbers in order. We figure out her median, her first quartile, her third quartile, and then you're just going to put hers below that. Okay, so, get you started, but basically you're going to do the same concept. Her median was 15. Her first quartile was 13, and so on. So you'd complete your box plots for Alejandra as well. All right, again, you do not need to copy this, but that's the idea of a parallel box plot. You're going to have one above the other. All right, let's talk about your homework, which we will do in the next video. I want to say, though, before we talk about your homework, that you do not have to do, I am letting you skip part A of 823. All right, we will do the second and the third part, but I am letting you skip part A. All right, I will do a second video for you on that information. Thank you.